Wanted to point out something about this tutorial, that it's a very simplified setup for learning. It's likely not what you would use in production. Most critically, we're using the PyTorch CPU-only version for the embeddings, and in production, you'd likely use cloud-based GPU. Additionally, we're using a very simple model, which is almost like it's barely usable. So this model here it's almost the smallest model that will give us at least some level of results. You would replace this, but it would take too long on our local computer for the tutorial. There's other databases, although you could use FAISS, but you should probably look into things like Pinecone or Weaviate. And this infrastructure is obviously overly simplified. Because we're using a CPU, it's slower. Because the model is small, there's limited accuracy. The processing, quite slow. It's barely usable in our example, although I think for the game, it is kind of useful. This is it's a good way to learn because there's zero cost, there's no credit card, you don't have to sign up for an external account, it works on old hardware, it works without the GPU. Sometimes these concepts, such as embedding, they seem rather difficult, and maybe it is difficult if you're to build the algorithm and the model for the embedding, but most people don't do that, right? You just have to be able to use the embedding model that other people have built. But you do need to know the terms because it's thrown about. So the embedding is a numerical representation of the text. So the text is our sentences in our game, and then there's a set of numbers, right? So we're using a command to convert the text into numbers. The numbers are stored in a fixed sized array of numbers. That's why we're using numpy as well. And because they're numbers, you can do comparison with algorithms. And you don't have to build the algorithms, right? You just use somebody else's algorithm. So, for example, dog and puppy will come up almost similar. This is termed vector database. And I think this is actually easier to understand. It's an array of numbers, and the array is multi-dimensional. Another tough sounding word, semantic. What does it mean? Everybody knows what search means, right? But semantic search somehow sounds rather difficult. It does a search based on meaning, not just keywords. And this sentence alone would be, well, how did it possibly do it? Remember, it's a set of numbers, right? And so you can compare how close the numbers are. Obviously, there's some magic as to how do you convert the sentences into numbers. Most people will just use the technique and the package that other people, the researchers have written. I think the first step is just to be able to use the package instead of being able to develop the package itself. Traditional search matches the keywords. Semantic search understands the context and meaning. So context, another, what the heck does this mean, right? I think you can just think of it as you're looking for similar meaning. So in our example, battle and fight will match, even though the words are different. Another keyword here is FAISS. And you're like, well, what does this mean, right? Well, it's the name of a package, the Facebook AI Similarity Search, and you just install it with import FAISS. So it's just a library with Python bindings, and you can use it. And it's optimized for large-scale vector databases. So it is very usable. You don't necessarily need to move off of FAISS, but you might want the more features, right? So we picked the easiest one for you to get started with the least amount of friction for your learning. And it uses L2 distance, Euclidean distance to measure similarity. And again, it's one of these words like, what does this mean? Like, how can I possibly use Euclidean distance in my programming? I don't even know what it is. Well, it's pretty simple because it's included in the package, right? There is this index flat L2 with you specify a number for the number of dimensions. And you can basically just copy and paste it, and over time, start to understand more about what this is. Maybe you might want to get into it for research and other things. But it just compares how far apart two vectors are. If the vectors are closer together, they're going to be more similar. The objective is to use FAISS to learn the concepts and then take the same concepts and apply them to the most likely a cloud-based solution because it's cheaper to get started with. You do have ongoing costs, but probably if you're doing it for work and not a personal project, you probably do want to bring it to the cloud. And there are many self-hosted options. The course was originally using ChromaDB, and I switched off of it. There's also extensions for SQLite so that it can function as a vector database. You can search for that. That was also in the earlier version of the course. And but there you could install Weaviate, Qdrant. So there's some things to consider in the self-hosted options. And although I've been saying FAISS is a vector database, it's actually not a database. We're actually pairing it up with SQLite to store the metadata from it. This is actually a library, and it doesn't have persistent storage. It doesn't have a lot of things on it, like CRUD, authentication, replication, but it does do the similarity search. So it's the easiest way for you to get started with the vector database concepts. You could continue on in your research using FAISS. It's free. It's open source. There's no other dependencies. You saw the import. It's just a UV add. You have full control over the infrastructure. It's great for prototyping and research, and then you have to probably move it to a actual real vector database. It's fast, although our system is slow. So there is this issue, but it is relatively fast. And there's no API rate limits. So you can just keep going and going with your project. And there's many cons to using FAISS. And you should be aware of it when you're making recommendations, I guess, to your team or maybe for your own project. So you know, like this one is pretty big, right? That no built-in persistence. It does add this layer of complexity where you need to store it as something else. And we're going to start an SQLite. These other issues, probably for prototyping, you need to be aware of it. But most likely for a prototype on your local computer or just showing people, it's probably okay. Parting message is that even if you have experience with FAISS and you build projects with it, you do need to be aware that there are alternatives and that FAISS alone is not going to function as a full vector database. It has several limitations, which is okay for our game, but it may not be okay for a enterprise or even a business data pipeline.